Good day po. We are group 1 and for our learning task, we have chose the shell sorting algorithm. And to demonstrate this shell sorting algorithm, we have made a program that sorts the attendance name or common last names and then sorts it in order using the shell sorting algorithm. So to demonstrate, we need to run the program. And to run the program, first is we need to open our terminal. Once we have opened the terminal, we need to locate where the Python file or the Python program is located at. So in my case, it is located inside this working directory. And then once you have located the Python file, you need to run it using Python 3 and then the Python file name. So in this case, main.py. So as you can see, when we run the program Python 3 main.py, prompt or a menu prompt shows. So it says here, this is an attendance alphabetical sort using shell sort. And we have 4 choices from 0 to 3. So the program prompts the user to enter their choice. So by going one by one on all the choices available, we will showcase how the program works. So first choice, if we enter 1, it views the attendance list. So for this example, for this program, we have created an array inside a text folder. So if we press or we enter option 1, this just views the attendance list inside this array.text. So as you can see, the attendance list is not alphabetically ordered. We also have an option 2, to add name into this list. So if we enter option 2, and then for example, I will add my last name, which is Martinez, and then I add it, it will say that Martinez is added to the list. So we can view that again if that worked by pressing or entering option 1 again. And then as you can see, my last name is now appended to the very last position in the text file. And now, if we want to sort the attendance list alphabetically, we just enter option 3. So if we do that, now, as you can see, the current attendance list now is sorted alphabetically. And then we have the option to save the sorted list. And if we press our enter Y, the sorted list is now saved to array.text. So if we check again, close this tab and then check the array text, as you can see, it is now currently sorted alphabetically. And now the last option is to exit the program. If we press 0 or input 0, it will say that it is now exiting the program, and then it will break out of the Python application.
Hello everyone, I will introduce you to the backend of this program. Now, let me explain how the codes operates in this sorting application. Let us now tackle the main program. Inside this file exists the shell sorting algorithm and the main menu. The shell sorting algorithm is almost similar to the insertion. It is a variation that sorts the items separated by the gap. The process of sorting is as follows. First, we get the gap by getting the number of elements of the array and dividing it by 2. Then, while the gap is not 0, we will keep looping the sorting algorithm, and each pass from the loop will reduce the gap by half until it eventually becomes 0. The next loops will iterate each element in relation to the gap, and each time the loop passes, the program will shift the element if the element is greater than the element at the gap distance. Once the iteration of the loop finishes, it will return the final sorted array. Next are the functions needed for the app to work. The load array function reads the array text file and inputs it to the array. The add item takes the input of the user from the program and add it to the file. The save sorted array rewrites the final sorted list in the file. The reset array is so that the sort does not rewrite the current list inside the program. This directly takes the data from the file to feed onto the program. The view array displays the current list, sorted or unsorted. Finally is the main menu. This displays the interface of the program for the user to navigate. Now we are done with the main program. Let us move to the comparison. This program will compare the sorting algorithm that we used against another sorting algorithm we chose. We chose insertion sort. The program will use the matplotlib library to display and animate the graphing or plotting of the steps made by each program. The insertion sort step and shell sort steps is a variation of the code of insertion sort and shell sort, only that each step are recorded into states so that the library will be able to read it and animate to the plot. Let's move on to the plotting. These lines of codes are what initializes the plotting of matplotlib library. First, you must set up the figures, the bars for the graph. Then, to animate it, this function updates the bar each steps of the sort. We also must control the frames so that both the shell and insertion algorithms sync with each other. After all of that, we will now initialize the program. First, we must add the data to sort. This program prepared two data to sort. One is the original data we used in the main program, while the other are random data with greater size. However, to emphasize more of the difference of the sorting, in this comparison, we will use the random data with greater size.
For the comparison, we have chose to compare shell sorting with insertion sort because shell sort is just an advanced version of insertion sort which just introduces the concept of gap. So first of all, we would like to demonstrate first how shell sort is faster than insertion sort, and we will compare the results and visualize it using matplotlib to plot and animate the sorting process. So first, to run the program, we need to open our terminal, and then we need to locate the Python file. So in my case, it is inside this working directory. And to run the program, we need to first locate the Python file, and then we need to be inside it. But in this case, I'm already inside the working directory. So we just need to type python 3 and then the Python file, which in my case is comparison, and then the Python extension .py. And then once we run this program, as you can see, there are two tables. The first table, or the top table, is the insertion sort, and the bottom table is the shell sort. And as you can see, each bar height represents a number. So the higher the bar, the higher the number that it represents. And as you can see, shell sort has already completed sorting from lowest to highest, while insertion sort is still ongoing. And this representation visualizes how shell sort is faster than insertion sort, because shell sort adds the concept of gap, and we will explain that diving into the code. So now let's delve into how this comparison or visualization of insertion versus shell sort works. So let's do this from top to bottom, covering all the functions and the concept of insertion and shell sort. So firstly, at the very top, we import the dependencies or the modules needed for this program. So we used the random module, and then matplotlib, the plot and the animation. So we used random to help us generate random numbers for our example of unsorted data. And below, we used matplotlib.pyplot to help us create the bar charts for the visualization. So as you can see, all of this is handled by this module of matplotlib. And then we use the matplotlib.animation to allow us to animate those charts. As you've seen before, the charts moved animated, so that we can watch the sorting process happen step by step. Now, delving to the first function, we have insertion sort steps, and it requires an array as its parameter. And as you can see, we define this function. This handles the insertion sorting algorithm. So firstly, it makes a copy of the array using a is equals to r, and then colon. This just reiterates over this array. And then we created a list called states, which records every step or change in the array during the sorting process. And then this helps us to animate the process later below. So explaining the concept of insertion sort, sort works the same way, like for example playing cards in our hands. So for example, we start with one card, then pick the next card and insert it into the right position relative to the already sorted cards. So in this for loop, we can see for I in range of 1 to the length of the array, or the array inside the copy array, which is we defined A. We determine the key is equals to the position of array, or for each position inside the array, and then j is equals to I minus 1. So this just says that we will start from the second element, because the first one we will already consider that it is sorted, and then the variable this variable key, this stores the current element that we want to insert into the correct place. And below that, we have a while loop, and while j is greater than or equal to 0, and a to the position of j is greater than key, we will shift elements that are greater than key one position to the right. So each time we move an element, we will record the new state of the array by appending it to A. We will append A to states. As you can see here, we append. So we will call the variable states or the list states, and we will append the corresponding array. Below that, we have A, and then the position of j plus 1 equals to key, and then we also append the array. So finally, when the algorithm finds the right spot, we will insert the key there and record the final step. So at the end of the function, returns all the recorded states, which we will use later for the animation process. Now for the shell sort algorithm, just like before, we copy the array and record the first states, and then here as you can see, we will introduce the concept of the gap. So shell sort improves on insertion sort by comparing elements that are far apart first. So initially, the gap is as you can see, we divide it or floor divide it by 2. So the gap is half the length of the array, and each time it gets smaller. So for each round of sorting, the gap gets smaller and smaller and smaller. So we say that while gap is greater than 0 for I in range of gap, and then the n, which is the length of array, we will create a temporary variable containing the index of array, and then we will equal j to that to the current reiteration of I. So this algorithm just continues until the gap eventually becomes 0. So for each element starting from the index equal to the gap, we compare it with another element located that many positions earlier. And then in the while loop, if the element a j minus gap is greater than the temporary variable, we shift it forward by the gap distance. This is like an example here where we performed an insertion sort on elements that are spaced apart, and then we record every step again for the animation process. And then once we break out of the while loop, once we finish each pass, we then now insert the element and reduce the gap by half. When the gap eventually becomes 1, shell sort essentially performs a final insertion sort, but by that point, the list is already mostly sorted, so the program finishes very quickly, as you have seen from the animation process before. So now we're here on the third function, so visualize sorting. So this function is mostly for the visualization of the sorting algorithm. So visualize sorting takes two parameters, insertion states and the shell states, which we have determined or have instantiate here in both the insertion and shell sort function. So we essentially create two subplots, so one for insertion sort, which is displayed here on the top, and one for shell sort, which is displayed here at the bottom. So so here we have a subtitle. So as you can see, this is here insertion sort versus shell sort visualization. Below that, we now draw the two bar charts. So each bar height represents an element in the array. As you can see, the range of the bar is equivalent to the length of the insertion states starting from 0. And for the color, we've chosen sky blue for insertion sort, and then salmon color for the shell sort. And then we just set the title. So this, for the ax 1, we set title for insertion 2, and then ax 2 set title for shell sort. And then inside we have another function. This updates the frame. So this inner update function essentially runs every time the animation moves to the next frame. We make sure that we don't exceed the total number of recorded steps for each algorithm. We validate it using the length function. So inside it, we have a for loop. So essentially, at each frame, the height of every bar, we update it according to the corresponding array states. And then this makes the bar move up and down visually, showing how the array becomes sorted over time. So outside that, we have frames, animation, and then two built-in functions of plot. So we essentially just create the animation itself. So it plays it at an interval of 100 milliseconds per frame until uh, both sorting algorithms finish, and then finally we can call the show function, which is just used to display the animation window. And then lastly, we have the driver. We say if name is equals to main, we set the initial size for the random list for 30 unique numbers, and this serves as the unsorted data for both sorting algorithms. And then we say data is equals to, we use the random module that we have imported before, and then we use the sample from range 1, and then we take the size of 30 unique numbers and then multiply it by 5. And then after that, we call the both functions to record their step-by-step progress. And then after this is done, this is now then fed inside the visualize sorting function. So just a quick recap on how insertion sort behave and how shell sort behave. So for insertion sort goes through the list from left to right. So for each element that it essentially moves backward, we compare and swap one element at a time until it finds the right place. So if, for example, the smallest number is near the end, it will take many comparisons and shifts to move it to the very front. That's why the time complexity for insertion sort is, for the base case, it's O of n when it's already sorted, and the average and worst case is O n squared. For shell sort, shell sort starts with a very large gap, comparing elements that are very far apart. This quickly reduces big misplaced elements and partially sorts the list. So as the gap shrinks, the list becomes almost sorted, so the final insertion phase is essentially much faster. So its average time complexity compared to insertion sort is about O(n) log n, which is significantly better than insertion sort.
Hello everyone, good day. So today we will talk about this learning task. The instruction of learning task. For each group, you are assigned one of the sorting algorithm like selection, exchange, insertion, shell, and radix. Please answer the following questions. First, in your own words, discuss your assigned sorting algorithm. How does it work? Compare it to other sorting algorithm previously discussed. Second, give your own real-life sorting example or problem. Third, provide your proposed solution to your given problem using your assigned algorithm. Write a programming solution using a Python code. Fourth, choose another sorting algorithm from the list and compare it to your assigned algorithm. How were the results? Which one executes faster? Why? Write a programming solution using Python code to validate the answer. Fifth, create videos or video showing how your program will work. Be sure to upload it to YouTube and don't forget to add your names to the video descriptions. Sixth and last, cite your references. Use say ACM citation, and this is the link. So we choose shell sort as our sorting algorithm. Why shell sort? Because it is fast and works well. lalo na kapag marami ang data na ginamit. So, compare sa ibang sorting algorithm tulad ng selection, exchange, insertion, and radix, mas effective ang shell sort sa long list. It does not just compare items next to each other. Instead, it uses a gap to move items that are far apart close to their correct place. The gap gets smaller each step until the whole list is sorted. Kaya mas mabilis at madaling gamitin ang shell sort sa malaking list. For our real-life examples, we choose attendance alphabetical sorting. In school, teachers sometimes have long and unordered list of students' names. Checking attendance in an order list can take a lot of time. Sorting the names alphabetically makes it faster and easier to manage. So, gamit ang shell sort, pwedeng ilagay lahat ng students' names in order. The algorithm first moves names that are far apart closer to correct place. After a few steps, most names are near the right spot, and the last steps organize the remaining names. The results is a clean and alphabetical attendance list in just a few simple steps. This method is faster than sorting by hand or using simple methods like insertion sort, especially when the class has many students. It saves times and also maiwasan din yung mga mistakes and helps teachers quickly see the full list. In short, ang shell sort is like simple and mabilis na paraan para maayos ang mga items or data rather. By moving items closer using gaps, it sorts lists faster and easier than basic methods. It is practical for organizing students' name, files, prices, or any kind of list. This tells how a small idea in sorting can make a big difference in managing data quickly.